Now the next problem, the problem is determine whether the 50 kg block shown in figure is in equilibrium and find the magnitude and direction of the frictional force when theta is equal to 10 degree. Take mu s is equal to 0.3, mu k is equal to 0.2. So this is the figure given. So block which is resting on a horizontal surface, the force of 200 Newton is applied at an angle of 10 degree. Okay. So to solve this problem, first of all we will draw the free body diagram for this diagram, considering this block is in equilibrium. Okay. Now the first thing is the weight of block. So weight of block W is given 50 kg. So convert into the Newton. 50 into 9.81. 50 into 9.81. So what will I get? 490.5 Newton. Okay. Now opposite force, that is normal reaction to this surface. Surface is horizontal, so it is vertically up. That is normal reaction. Now this force is inclined at 10 degree. So resolve this force into x and y component. Okay. So this is y component, that is 200 sin 10, and this is x component, that is 200 cos 10, right? Now as we consider this body is in equilibrium, so first of all get summation Fy which is equal to 0. Okay. So what are the forces in y direction? This and this force. Okay. And which is up minus W, that is 490.5. Okay. One more force is there, minus 200 sin 10. Okay. So N is equal to 490.5 plus, solve this. So sin 10 into 200, you will get 34.72. So finally N is equal to, add 490, so it is 84.22. So I think we have done some mistake here. So it is 490 plus 5. So 490.5 plus 34.72. So it is 525.22 Newton. Okay. So this is normal reaction we got. So with this normal reaction, how to get the maximum frictional force? Maximum frictional force. How to get the maximum frictional force? We know the maximum frictional force formula. F max is equal to mu s into n. See here, we need to find whether it is in equilibrium. So this block is in equilibrium. Okay. And when this block is in equilibrium, we will use the static coefficient of static friction. Okay. So mu s is given 0.3. Normal force we have calculated 525.22. So get this value, 0.3 into 525.22. So the F max value is 157.56 Newton. So here we got the F max value. Okay, what will be the maximum frictional force? That is 157.56. Okay, but as per the given condition in the problem, we see. So what is the friction here? summation fx, it is 200 cos 10. Okay, so here summation fx is 200 cos 10. So by solving this, what will get? Cos 10 into 200. Okay, so here it is 196.96 Newton. Okay, so if we compare this Fmax value and EFX, Fmax value and summation of Fx. Okay, so summation of Fx is greater than Fmax value. Okay, 196.96 is greater than 157. Means what? It is exceeding the limit of Fmax. Okay, when any force exceed the limit of maximum frictional force, then what will happen? So that object will move. Okay, so object will move. Okay, now we need to find, now object is moving, we need to find the friction when object is moving, that is kinetic friction we need to find. So what is the formula for kinetic friction? Kinetic friction Fk is equal to mu k into n. So which is equal to, mu k value is given 0.2 into the normal reaction is given 520. We have found out the normal reaction 525.2. To solve this, 0.2 into 525.5. So it is 105.1 Newton. Next problem is, knowing that WA is 25 Newton and theta is 30 degree, determine the range of values of WB for which the system is in equilibrium. Assume mu s is equal to 0.3. Okay, so the value of theta and the value of A, the weight of block of A is given. We need to find the range of value, the range of weight of block B. Okay, so range means there will be a minimum value and maximum value. Okay, so first we will solve we will get the smaller value. Consider this case 1. Okay, now imagine the weight of W is smaller. Okay, so we are going to find the two values, smaller and is minimum and maximum. Consider this value is minimum. So what will happen? This value is minimum means this block will try to move in upward direction. Okay, as its value is minimum. And if suppose it moves in this direction, its friction will be is in this direction. Okay, so first of all, draw the free body diagram for this system, for this case 1. Okay, draw a separate free body diagram for block A and block B. Now consider the block A. Okay, so its weight will act downward, that is WA, which is given 25 Newton. Right, now if you see this block A, it is in the air, it is not resting on any surface. So here there will not be any normal reaction. Okay, only tension, because the wire is attached, so the tension will develop in this rope. So it is denoted by T. Okay, now coming to the inclined plane, this theta angle is 30 degree. Okay, here it is a block B. Okay, now as this value we are considering smaller, it will try to move in this direction. So this will be tension T, that will be same of this value T. Okay. Then as it is resting on surface, perpendicular normal reaction, consider this as a NB. Okay, weight of the block will act downward. Okay, so that will be WB. Okay, now consider this horizontal plane. okay, and resolve these forces, resolve the weight of block. Okay, so it will be W cos 30 and here will be W sin 30. Okay, this angle is 30. Okay, now see here for the block A. So for block A, okay, so if it is suppose in equilibrium, summation Fy will be 0, right? Then T are going upward, so positive, minus WA is 0, so T is equal to WA, which is equal to 25 Newton, right? Now for block B, for the block B, so consider summation Fy is 0. Okay, so what are the forces in Fy? Y direction, this force NB, which is going upward, normal force. Then this force is going downward, so minus WB cos 30, which is equal to 0. So this we can rewrite as NB, which is equal to WB cos 30. Okay, okay, now in x direction, summation Fx is equal to 0. Okay, so what are the forces in x direction? You can see here. Okay, one in this direction T, one in this direction, that is WB sin 30. Okay, now we are considering the first case in which the value of weight of B is smaller, so it will try to move in this direction. If suppose it is moving in upward direction, so friction will be in opposite direction. Okay, so this is friction value. Okay, so these are the three forces. Now, summation Fx is equal to 0. So WB sin 30, one force, plus F minus T is equal to 0, right? Now W, again rewrite this, W sin 30. So what is F? F is equal to mu S NB, okay, for this condition. Okay, so F is equal to coefficient of friction mu S into NB, right? Now mu S is given 0.3. Okay, NB, here we have calculated NB value, normal reaction for block B. So WB cos 30, okay, minus this T value, tension value we have calculated here, 25 is equal to 0. Now solve this and you will get the value of WB. Okay, so sin 30, 0.5 WB plus cos 30 into 0.3, so 0.259 WB, which is equal to 25. So WB is equal to 25 divided by 0.759, addition of these two. So W is equal to 25 divided by answer 32.90. So this is our value for block B. This is the first value, that is smaller value. Now the second case, for the maximum value of WB, weight of block B. Okay, so we will draw the block diagram. So this is block A, weight is going vertically downward, and this is tension T. Okay, this is inclined plane, inclined at 30 degree. This is block B. Okay, same as it is resting on this incline, so perpendicular to this is NB. This is tension T. Okay, now if suppose the weight of block is maximum, so what will happen? It will try to move in this direction. If suppose weight of block is minimum, it will try to move in this direction. As weight of block is maximum, it will try to move in this direction. Okay, if suppose motion is in this direction, so friction will be in opposite direction. So here we will get the friction. Okay, so its weight will act downward, so it is WB. Resolve this force into two direction. First is this, that is WB sin 30, and second is this one, that is WB cos 30. Okay, now using the same procedure you will get the answer. So first we will calculate for block A. Okay, for block A only two forces which are in y direction, so summation Fy is equal to 0. So why we are taking summation Fy, summation Fx is 0 here? So we are considering this is in equilibrium. In the problem also it is given, we need to find the value of block B so that the system is in equilibrium. So T minus 25 is equal to 0, T is equal to 25 Newton. For block B, summation Fy is 0, summation Fy. So what are the forces in y direction? NB minus WB cos 30 is equal to 0, NB is equal to WB cos 30. Again, summation Fx is 0. Summation Fx is 0. So what are the forces in x direction? So this WB sin 30, it is in this direction, so plus. So plus WB sin 30. Okay, now two forces are in opposite direction, so minus T minus F, which is equal to 0. So F we know mu S into NB. Okay, that is 0.3 into NB. So put the values. WB sin 30 minus T value is 25 minus 0.3. Okay, NB value is here WB cos 30, which is equal to 0. Now solve this and you will get the value of WB. So sin 30 0.5 WB minus cos 30 into 0.3 0.259 WB, which is equal to 25. Okay, so 0.5 minus this 2.259, so WB is equal to 25 divided by 0.240. So your answer is 104.08 Newton. Okay, and to summarize, so here you got the minimum value 32.9 Newton, okay, which is less than equal to W. And what is the maximum value? 10.08. Okay, so this is the range of values of weight of block B, such that your system will be in equilibrium.